Hi everyone, and welcome to what's going to be a bit different, but also what's I think about day 15 of my 65 days of TypeScript challenges. Today, I what's different is that I'm going to be going through a ton of challenges at once. So I actually did this, I think it was last week, but I eventually ended up not recording with my audio on. So I stopped when I realized that um, around halfway through all the easy ones. So yeah, I just wanted to do this, go through all of them, make sure that I remember the techniques that came up to solve them, before going ahead with with further challenges. Um, that's going ahead to the medium challenges. So yeah, that's pretty much it. When I was solving this, I noticed that there were similarities between a pair, like two pairs or three pairs of them, and I just thought it would help to have a condensed summary of how to solve them as a go. So starting with pick, um, while that loads in the new tab, pick was all about you have a set of properties and you want to select from an object only those properties that you have, right? And pick taught us how to index into an object type in the type space and just how to select those properties. So let's head on quickly into that. Um, well, let's do one by one. So that's pick. Let's go into pick and implement pick. Okay, I might as well just have Readonly loading background as well. Yeah, so pick, quick overview. You have a type and you want to pick from the type the properties title, completed, the type to do title and completed. So the idea here is we utilize the concept of mapping through the properties of a type. So we do something like property in T, where T is the object type. In K of T, we then want to select properties in P and K, I believe is what we want, because K actually is the list, roughly speaking, of the properties that we're interested in. So we're going to look through all the properties in K, and then we're going to index into T and select those properties. TypeScript complaints. As we go through this quickly, you'll note that these complaints have to do with telling TypeScript what to expect. So we are expecting K to be key of T. I think that's about it. And this one says, and we're expecting T to be to do title completed. Title completed. Title completed. So that's not equal. Ooh, what's the issue? P in KTK, but false. Expected to. Okay, here. So we have expected to title string completed boolean to equal my pick to do. Let's just see what we're actually getting from my pick with this test case. To do title completed, I think that's what we want. Type C. What do we have? String or boolean. String or boolean, which is not title. We want one to be string and we want the other one to be boolean. So K extends K of T, yeah, and then for every P in K, for every property in K, oh sorry, TP, we made a mistake there. We're meant to be looping through. assigning every property in K to P and then using P to access T. So that's the issue. That's basically shows us how to index into an object type like T using a property P, how to map through a union type like K, using the something in something syntax. So that was what we learned with the pick type. Let's move on to the read-only type. But while we go over to the read-only type, I'm just going to load over the tuple to object type. The read-only type taught us about how to prepend properties, how to prepend keywords to object properties. The idea being we have an object with all its properties, and we want to make sure some of them are read-only. I think it's actually want to make all of them read-only. So let's take the challenge. Okay, seems like we're gonna have to wait. Okay, cool. And the example is given a type to do title, description, properties. The output will be that all those become read-only. Anyway, so we already learned how to iterate through a type. We're going to do that again. We're going to say something like TNT and TT. But we want to make everything there read-only. What's it saying? It's saying that in K of T. Okay, so that's cool. So what we've done is we have enumerated all the properties of T, and then we're looping through all of those, and at each point each property will temporarily be stored in the T subtype, in the T type variable, and then for all those we're going to assign that property to, this is going to resolve to a property, right? Like for instance, this is going to resolve to title, and then we're going to go into T itself to do, and what we're doing here is like to do title, which will give us a value string. So all we'll have is title string, and as we build up all of those, we'll prepend them with read-only. So that's how that works. Test case is passed, so I think that's good. So this just teaches us that with looping, you can also have like this thing where you can add a keyword in front of the property definition. So let's move on from read-only to tuple to object. Tuple to object was an interesting one. It involved like going through two phases. First of all, you take your tuple, you convert it to a union, then you take your union and you convert it to an object. The brief was basically that given a tuple, you want an object where the values are the properties, and the key value pair takes on, so the value in index 0 takes, the key value for index 0 becomes Tesla, then model 3, model 3, model X, model X, model X, and so on and so forth. So basically if you have a tuple, you get just Tesla model 3, you get an object where you have Tesla, model 3, etc., etc. I think there are other ways people are tempted or achieve doing this, but the way I remember is, first of all, given a tuple such as Tesla model 3, model X, model Y, first convert it to a union type or an intersection type. And the key learning for how to do that was just to go in and say you want to do that T number. Alright, so if we type C, if we do it like type T and we go to tuple, we do tuple to object, and we pass in let's see, type of tuple. So we have a tuple here as a constant. Let's pass in type of tuple. That's a small, okay, cool. What we get here should be a union type here. So we have, so see, we have in the tuple Tesla, model 3, model X, model Y, and then when we kind of like say Typescript, iterate through, access all the values of this tuple at once using the syntax T number, that just gives us a union type. I don't really understand why that's the case yet. I haven't read deeply into it, but so first of all, we have that. Now that we have this, I think it's easier to see that we can then just do the mapping thing we did in pick and we did in read-only, and then as we map, we use the property, we use the value as the property, and we use the value as we use the value as the key, and we use the value as the value. So we have t number. So we can just wrap this around in the objects in the curly braces, and then we'll say something like, oh, wrap this again in the map, in the map scope. It's always like a array kind of thing. So we'll now say, let's say k representing keys, k in t number. Let's just do k. So seems like we're done. Just a sec, we're not fully done. There's an error here. We're not fully done, but we do pass the first test case. And actually, let me undo what I just deleted and say type of tuple. What do we get? Do we get our object? Yes, we get Tesla, Tesla, model 3, model 3, model X, model X, model Y, model Y. This error is telling us that okay, so one thing about objects here is how do I explain? So the key in an object type or in an object can only be of type string, number, or symbol. And I think we should expect an error because, so this is telling us to expect an error when we're trying to use an array and then an empty object as values for our keys. So it's telling us we should expect an error, but this isn't giving us an error. So what do? We've already told Typescript, the tuple to object generic type, that T should be a subset of a read-only array of type any. I think the way I simply passed this was to say, given I know what the valid sets of types of keys should be, I'm just going to do that. I'm just going to tell Typescript I want to expect a string, a number, or a symbol. And yeah, that solves it. So these are not apparently string numbers or symbols. So without this line here, it throws an error telling us that type that doesn't satisfy the constraint that, right? Type this or this is not assignable to type string number or symbol. Type empty object is not assignable to type string number or symbol. So that tells us that we can't use it as a key, and it stops us. Now the beautiful thing about this is we know we should expect an error, so we kind of say TS expects error to ignore the squiggly line. If the error comes up, then everything looks cool. We expected an error, there's an error, you silence the error, we're happy. If we expected an error but there was no error, like there was no error just before I updated this to say string number or symbol, it says, hey, you expected an error, but you're not getting an error, fix up. So that's that. So the key learning from this was we just used our knowledge of union types. We used our knowledge, and we learned very key learning here is we learned how to iterate through a tuple type in a parallel manner. Like, I think it's like parallel iteration, but it just says give us the output when you go through this union type from this tuple type from 0 to 1 to length -1, right? And just spits that out as a union type. So tuple type in array access syntax number, remember that. So that was for the read-only challenge. Sorry, tuple to object challenge. Next challenge was first of array, and this is such a super simple one. And it brings home what we're doing with T number when we're accessing all the indices of a tuple type, by telling us to just access the first index, not all of them, just the first index. So what we have is, given a tuple type, here we have 3 to 1, here we have a function, an object with a string, here we have an empty object, here we have a tuple where the first type is undefined. Just return the type in the first index. So here we return 3, here we return the function that returns 1 to 3, here we return never, because there's nothing in the first nothing in the array, and here we return undefined because the first thing is undefined. And this is how we return never when there's nothing, and undefined when there's undefined. Key thing here is go into T, which we've defined will always be some sort of array of types, of any types, and just access the first element. Oh, sorry, the zeroth element. That's pretty much it. Now there's a complaint. There's a complaint saying this should return never, right? Okay. How do I explain? The way I made my peace with this is by going back to memory allocation when we create memories, when we create arrays in memory, and you're like, first of all, you tell, say, maybe it's a language like Java, you tell Java, I want to have an array. Sometimes you don't give it the length of the array, so it just allocates, I guess it just allocates space that has space on either side or just on one side to grow. Or maybe just allocate space and then moves it around later when you add something. So with an array, you can say I want space for n numbers without actually putting anything in any of those indices. So let's say the array is just a length of 1. I want space in memory for an array of length 1, and that exists there, but there's nothing there, right? So when we go there initially, and we're trying to access array 0, we should get undefined. Yeah, we should get undefined. But when we do put something there, we should get something. The way I made peace with this was to say what we're doing here is we have a tuple, and it doesn't have any space for anything. It doesn't have any space for even one value, for even length of one, for even one item, right? So it will never have an item in the first index. So we should never return a type, but instead what we're returning is I wonder what we are returning here. I'm actually curious now. Type C. I have no good guesses. So first, and then undefined. We don't want to return undefined. We want to say, hey, we don't even have any space to have an undefined value in the first index of this array. We want to say there is never going to be anything in this index of the array. I think that's the aim that we're going with here. I don't know whether that's useful, but yeah. So instead of returning undefined, we want to return never. So what we're going to do is just say t extends any array. Let's see. T. Let's check if t extends an empty array. If it does, return never always. Otherwise, if it doesn't, return go into the first index and get the value of the type that's in the first index. So we could have done I think we have done this other ways. If t extends something that has a length property, because basically I think that's fine. Then 1, then return sorry, let's just say length 0, just to say these are the same thing. We're doing the same thing here. TypeScript arrays are interesting because arrays are I don't want to say something that's wrong, but yes, I think in JavaScript everything's an object anyway. Arrays are objects, and they have length properties, and the length properties are just properties of how many elements they have. So doing it this way and doing it this way is basically the same thing. You're extending something that is of the type of an array object with a length 0. Yeah, so what was the key learning from this? That I think the key learning from this was to realize that with TypeScript you're really working with JavaScript and you're working with objects at the end of the day. When working with something like empty arrays, you can remember that they're objects if you want to remember the object as well as they can be looked at as objects, just as well we did here, or they can be looked at as arrays, and they can be indexed into just like would index into typical value space arrays. So that was it. That's pretty much it for the first of array challenge. Really simple, really nice challenge. The next one was length of tuple. In my head, whenever I see tuple in the type space, I'm always like, oh, array, because it's just so similar to an array. It's what is a tuple actually at the end of the day? I've always just memorized it or recalled it as a fixed length array, where each number corresponds. It could be a tuple of strings, where each number corresponds to a string, and so on and so forth. So, yeah, this challenge, length of tuple, is built upon, I think, our learning from the previous challenge by really driving home that we can think of tuples, we can think of arrays as objects in JavaScript, and the challenge asks us to return the length of the tuple. Simple. So we're given here a tuple of length 4, here a tuple of 1, 2, 3, 4, 5, 5, right? And we're expecting that when we return the length, when we use a length, when we create a length generic type or utility type, we'll return just that, the length of these tuples. If we remember to think of, first of all, let's constrain this to say that we're expecting some sort of tuple. This is a read-only. Oh, we have issues here. Cannot find name expect equal. I think we need to reload this. I don't think it loaded properly, and my Mac is dying. Let's put that into charge. Awesome. Okay, cool. So I think these are loaded properly. Yeah. So the first thing is, unlike the previous challenges, notice that they haven't in this challenge bothered to constrain our input type, our input parameter to our generic length type for us. So what that means is we have to, just like we would specify in statically typed languages, like Java, what types we expect, string, number, whatever class we're expecting. We need to do that here, but the way we do that with TypeScript most of the time is using extend. So we just say that we expect this to be a subset of some other type. We expect this, in this case, to be a subset of some array type. So an array where the values could be anything. That's what we expect here. But that's not enough. These are tuples. We've used it as cont assertion, and that means that these are read-only arrays. So we're going to add that over here and say we're expecting things that are read-only. Cool. Finally, we are just going to go into T, and we are going to index into the length property, and that's it. Because T as a tuple is, well, an object, and although we can't use in the type space the dot notation as we would be able to use in value space in JavaScript, we can use the I think I'll just call this box notation because I don't remember the official name. And we can access the object that way, just like we can access the property of the object that way, just as we can access properties of any objects similarly. So I think that this just drives home that we can think of a lot of things in JavaScript and TypeScript as objects. So moving on to the next challenge, exclude. Oh my goodness, exclude. The first time I did exclude, I felt like ripping out my hair. It wasn't easy. It was not easy. It wasn't easy because I think it involved building up your own. Okay, so first of all, actually, let's do this. Exclude says you have a union. You have a set of. You have a union of types, right? And you have another union of types. No, chill. What am I doing? Okay, so let me highlight. So you have a union of types. Here you have A, B, C on the left hand side, and then you have a smaller union on the right hand side. it's not necessarily a smaller union, but basically everything on the right hand side that exists in the left hand side, you want to remove it. So at the end of the day, when we run exclude A from ABC, what we should get is BC. If I hover over this, does it give me the answer? No, it just gives me the type of exclude. Okay, that's basically the gist of it. This involved some deep thoughts. And I was surprised it was an easy challenge because, oh my god. And it touches on concepts of TypeScript that I found very interesting, very beautiful, that I'm going to read up more. Symbols. I think this was the first time I really understood, oh, that's what a symbol is. That's what we could use a symbol for. Symbols. Symbols come in later when we're trying to do an equality check. And I'll explain when we get there. So it touches on symbols, it touches on just Boolean logic, I think. And so let's just jump straight into it. So we'll first do the Boolean logic part. We'll wait. This is excludes. Maybe I'm jumping the gun here. So excludes is yeah. So sorry, includes is the one that involves symbols and maybe Boolean logic, but excludes I think is much simpler. Sorry, because I just looked at this again and like all we want to do is remove from ABC what's on the right hand side, right? Yeah. I don't think I remember exactly what went on with this one. So okay. Okay, I think the key learning from this was rather than always trying, union types are a very special type. I haven't wrapped my head around them. Rather than always trying to map through them one at a time and do value by value comparisons, we can actually try and just do set comparisons as a whole. What I mean by that is looking at the first test case ABCA. What we could do is for every item on the right hand side, right, which in this case is just A, if it is on, we can, for every item on the right hand side, if we find it on the left hand side, then we just remove it. We just remove it from the left hand side and we return what's left. Easier said than done. When you try to do that, you come in and say, so what you come in and say something like what are we trying to do? For every U in U, you basically want to do something like, I don't know, T minus U, T minus small u. Problem is, this isn't, I mean, I think you can see the logic here. So U here contains A, U is A, and then T is ABC. So for every U in U, so we start with A, we do T minus A, so we do like ABC minus A, which is BC. But problems abound. First of all, this syntax will leave us with a key value object, not a union, where we would have A, and then we would have, for every A, we would have like T minus A, so A, BC. In this case, we'll have A and then BC, if this minus thing worked. Alternatively, we could wish that we could do something like T minus U, but we don't have a minus thingy. We don't have any way to do that. So rather than doing that, the solution to this involved going into T, taking T as a set on its own and saying, does T extend U? If T extends U, we're returning, if T extends U, we're returning, what are we returning? I think we're returning T else U. Okay, ULT. I'm going to think about it on an individual level. So let's say we have A. If T extends something from U, then we will return never, actually, because we don't want it, right? Else we return T. Okay. Now, I struggle to understand this, sorry, to recall this, because I still don't understand it. When I saw the solutions, I realized, oh, you can actually loop through, you can actually treat union types. So T is a union type, U is a union type. In an extent, perhaps not just in an extent operator scope, but in any operator, you can actually treat them as though you're treating individual elements in the union types, because the way I understood it is to think as this T here as just an element in the union ABC, and to say if, for instance, A extends another element in the union U, any element in the union U, then we don't want to return anything, so return never. But if it doesn't, so like B, if it doesn't, B doesn't extend A, then we return B. If C doesn't extend A, C doesn't extend A, we return C. So that's how I understood it. Like you're treating these sets of values as though they're individual values. I don't know why that works. Something I'm going to read about, but this is why I learned that you can actually do this with union types. And I wonder if we return unknown, whether it also works. No, it doesn't. Unknown is some sort of thing. Never. Is there anything that's less than never? Not that I can recall. Okay, so that's what I learned about TypeScript from this challenge. You can treat union types as though you're working with the individual elements of the union types. Moving on to the next challenge. The next challenge being awaited. Ooh, I loved awaited. Awaited was like, I think the first and only thing in the easy grade challenges that involved using recursion. I loved it because I struggled so much with it. I struggled with it so much, but it was one of those things where I was close. The logic was close, but the implementation was just wasn't there. So awaited says, if you have, let's just look at the test case. So if you have, so type X is a promise that takes a string, right? Awaited says return the awaited says return the awaited type, basically, right? When you have a promise that this is a promise of type string, you're going to get a string at the end of the day. Here you're going to get an object with a field, key, and number value at the end of the day. Here you're going to get a promise, but that's going to resolve to a string or a number, so you're going to have to return the string or number. So basically what it says, return this thing in the innermost promise. Yes, in the innermost promise. In the last nested, I don't know what to say. Innermost, I think, is not a word, but I think makes sense in explaining what we want to do here. So that's my awaited. Here they've gone a step further and forgotten to even give us like the parameter construct. So we're going to do that. We're going to say we expect something, a type that extends a promise, and this promise takes an unknown type. So that's what we're going to do first. That's what we've done, and the logic is basically saying, hey, let's check if that T. Oh, we learn to use infer as well. How do I explain it without actually just coding it? So first of all, we say we're expecting a promise and we don't know what type that promise will resolve to, so it's taking an unknown type. The next thing is we're going to go more specific. When we're on the right hand side of this type definition, we can then say T is actually a promise, and then that promise takes a type that we infer, and then when we infer that type, so let me type it out at this point. So it's just like we're repeating ourselves. Extends a promise, and we're going to infer the type, let's say U, that promise takes, For now, let's say false, false. So infer is such a beautiful operator. It's like you can't infer here in the you can't, as far as I'm aware, infer in the parameter scope of a generic type, but you can infer um, in the body scope, right? And only when you're doing an extend, if I'm correct, only when you're using an extend as well. Another thing about infer that I learned is the inferred value can only be used in the positive part of the operator of the ternary operator question mark colon. So we can't use u here. If we try, it's going to say u doesn't exist. We can't find the value of u. Cannot find name u. So I think once you know these rules about extends and infer and where you can use the inferred value, then things get easy. First time I was working on this, I did not know any of these rules. Like, oh my god, like, and it's not intuitive and it's not really that well documented. So I actually had to spend a bit of time looking through the TypeScript documentation to understand what was going on here. But yeah, at the end of the day, I found it fun because what we're basically going to do is say if t extends a promise and then we infer the type that the promise takes, we're going to check if the type that the promise takes is a promise. Now if that's a promise, clearly we want to recurse passing u, if u is a promise, into my awaited, and just keep going until we get to the point where t extends a promise and the inferred type u is not a promise. At that point we've reached the base case of the recursion, right? And then we can just return u. Question is, that tells us we need two ternary cases. The way I like to nest ternaries is I can't remember. So we need another ternary where we say u, let's just say u, and then it's so hard to see. True. Okay, chill. First of all, the first ternary is t extends a promise. If it extends a promise, then that's what we're going to work. T will never not extend a promise, so we're just going to put this as never here. Convince yourself that this is true because we have already done a check at the parameter level in the parameter scope that t extends a promise. So when we come into the body scope and check again whether t extends a promise, we're not really checking whether t extends a promise. We're just doing that for the purposes of inferring the type that the promise takes, not checking. So t will never extend the promise, and so that's going to be never. T will never not extend the promise, so that's going to be never. The false case is going to be never. Now we can come in here and then do a check to see whether u extends a promise. And if it does, we said we're going to recurse on my awaited, otherwise we're going to return u. Let's do the recurse on my awaited here. My awaited with the value of u, with the value of t extends the promise. So something seems wrong. Oh, I think that's okay. Right, so here t extends the promise. I think we can just do any. Doesn't matter. We don't need to infer any further. So t extends a promise, and then we infer the type of the promise takes. Then we take the type of u, which we inferred, and we now check if that extends a promise. Then we haven't gotten to the base case yet. We want to recurse, so we continue. We recurse with that type u. And if it doesn't extend the promise, then we've gotten to the base case. It's probably a string, it's an object or something, so we just return that. And that, folks, is how you implement the my awaited type. That I don't know, I think I spent like 2 hours on that the first time around. And I think what I learned from that is just to respect that some things are difficult. This was difficult and needed time, needed more study, needed understanding of how extends worked, needed understanding of how infer worked, how you can only use the again something that the how you can only use the inferred value in the positive section. So if you were asking how come I'm using you in the negative section, the answer is I'm not really using you in the negative section. All of this belongs to the positive section of the first first ternary. So I can use you in anywhere here, right? I can't use you here as I demonstrated earlier. And I think that's pretty much it. So yeah, needed needed you need to understand that about inferred types, where to use them, about extents, and just about this pattern that we're going to use again in another challenge shortly, where first of all you extend something just to paint out the general shape of it, and then you can go deeper into that thing and actually extract the more specific types that you're looking for. In this case, in you versus unknown. I'm going to stop here now for this challenge. I just love this challenge. And we're going to move on. So that was awaited. If was another super simple challenge, just using the ternary operator. If was basically saying you're given three parameters. One is a boolean. One is something that extends a boolean. If that boolean type is true, then return the second parameter. If the boolean type is false, return the third parameter. So let's quickly implement that. There is really nothing here I think that's new. I think any TypeScript novice will actually be able to implement this. So this extends boolean. This can be anything. I know this because I've done these challenges, obviously. Oh, we don't need that. So all we're going to do is basically say if C extends true, then we want to return T, else return false. That's basically it. Like I said, this was a very simple challenge. Let's not spend too much time on it. Let's move on. Next one is Concat. Concat was just like what you'd expect, concatenation of an array in JavaScript. But I went into it thinking, oh yeah, concat, it must be just the same syntax. And it ended up being the same syntax. You have two tuple types or two array types. And all you want to do is concat. And what did I do? I think I came here and I did something like T and U. And there was an error and I was like, oh no, that doesn't work. But this really taught me to look at the TypeScript error message, right? I just saw a squiggly line. I was like, oh no, that means it doesn't work. That syntax doesn't exist, because I had read through effective TypeScript and I hadn't seen this anywhere. I mean, I guess I didn't read so thoroughly that I would definitely have seen it if it were mentioned or used in one place, but it wasn't widely used. I didn't really see it at a glance in the TypeScript documentation. I was like, oh, if there's an error, then it's definitely not valid TypeScript syntax. But I was wrong, and I was wrong, but I immediately went away, erased this, and I tried all sorts of things. I wasted so much time, and it caused me so much pain. So folks, lesson from this challenge was read your TypeScript error messages. It's just saying here that a REST element type must be an array type, and that simply means we need to tell TypeScript that this is an array type, and this too, same error message, this too is an array type or a tuple type, and that's it. If I had read the error message the first time, I would not have fallen into so much pain. So that was all for this challenge, concatenation using the REST parameter, the REST syntax which you use in arrays or spreadable objects. So let's move on. That's concatenation. I think the next thing here is includes. Yeah, includes. So includes sounds like excludes, and when we were at excludes, I was like, oh, this was such an, but I was wrong. What I thought I was talking about when I was talking about excludes initially was includes. Includes is what was so interesting. I think aside awaited, includes is the most interesting challenge of the easy challenges. Um, include says that if you can find cars in the tuple, return true. If you cannot find deal in the tuple, return false. You cannot find the type on the right hand side in the tuple, return false. If you can find it in the tuple, return true. Okay, let's just leave that as usual. Let's do a check. So T extends a read-only array type, and then you have some type that's any type. And how to begin to explain this? So this involves some knowledge of Boolean logic. Of if you have a union of truths and falses, and you create the union of them, what do you get at the end of the day? Answer is, if there's ever a false, you always get false. If there is no false, you always get true. So if you have true, a union of all those, and you don't have any false, you will get true. If there's even one false, you will always get false, no matter the ordering. So that's Boolean logic for you. False overpowers true. And so, from a naive point of view, looking at this, you want to go through every element in T, right? Something like T in T. You want something like maybe T extends. Let's do T in K of T and then index back into it, right? T of T extends you then return true, else false. Think about this. Let's see what that gives us. I hope this makes sense, because basically what I'm doing here is I'm going through every element in T, so cars SCDC, WAMU, and Santana, and I'm checking if that element matches basically U. If it does, I'm saying return true, else return false. Before even looking at what this gives us, we should probably expect a situation where we have the values of the tuple as keys of an object, and then true or false as the values of the keys. So let's see actually what our includes gives us for the first test case. Includes type C, includes. Okay, we've done that. Let's remove that there. What does that give us? Oh, it gives us a tuple of true, false, true, false. Oh, cool! It gives us a tuple of true, false, because we're doing key of T. The keys of T of this tuple are 0, 1, 2, 3, 4, and so on and so forth. For T in key of T, for 0 to N, and we're assigning into 0, into 1, into 2, and so on and so forth, true or false. So we've successfully converted a what do you call it? we actually jumped the gun. I was hoping this would give us an object hook, but anyway, we successfully converted a tuple of values of non-boolean values to a tuple of boolean values. Okay. Now let's put. It's so hard to explain. Answers in my head, but I'm trying my best. I'll try my best. Let's see. Say we have the value we're looking for in the tuple, right? And we convert this into a boolean tuple, a tuple of boolean values, true or false, and then we get the union by just indexing into that with number. So what I mean is, we go into here with number. What do we expect when the value is in the tuple versus when the value is not in the tuple? Here's my answer. So cars is in this tuple, right? So we're going to have true, and then we're going to have false. We should expect a situation where if we find the union of all those truths and falses, we get false, because we have true and we have false, right? So we should get false here. Here, Dio is not in here, so we're just gonna get false anyway. Yeah, so basically, for anyone where it is in there, but their values, is there anything that's just a one value? Basically, at the moment, if it's in there, but there are also other values that it's not equal to, we'll get false. If it's not in there, we'll get false. But more specifically, with TypeScript, what we'll get is actually a union of here. Cars is here, so in the first index, let me remove this number. In the first index, we'll get true, and then the next, in subsequent indices, we'll get false. When we create the union, when we convert this into a union type, what we have is a union of true and false and false and false. Essentially, that reduces to just a union of true and false. In TypeScript, a union of true and false is a boolean, right? So here we'll get a boolean, and let me demonstrate that by just then doing the conversion, using the conversion syntax from tuple, boolean tuple to union tuple. And what we have here is boolean, right? Because we had true, we had false. But if it's something that's not in there, we'll only ever have a union of false, and so we'll only ever get false. So here we should just get false. So we can only get so now we have a key, like an axiom, right, where if our value is in this tuple, we can expect a boolean or true. We can expect a boolean or true. True if we only have one. True if we only have just one, a tuple of length 1. So let's remove all of this. Yeah, so that passes. I don't think that's a test case that was covered here. Maybe we'll contribute back if we see if it makes a difference. So if it's in there, we're going to see true or we're going to see boolean. If it's not in there, we're going to see false. How can we work with this to complete our type? We can say that if this extends boolean, let's return true, else return false. But now, oh no, false extends boolean. Let's do it this way. If this extends false, return false, otherwise return true. Okay, cool. So that works for our, there's a unique case where if the value is not in the tuple, we know we'll always expect false after we've converted it to a union type. So when we check whether that conversion and everything, let's highlight it right. At this point, we have a union type. When we check whether that union type extends false, if it does extend false, we know it's not there. We return false. If it extends something else, if it extends boolean or true, then it's true. There's a value that is in there that matches the value we're looking for. That's step one. We've mostly solved the problem. Step two was where most of the interesting aspects of this challenge laid in for me. So observe here that we are checking if boolean exists in this tuple, and in this tuple we have true. True extends boolean, and we do that by checking one by one whether any of the values in this tuple extends the value we're looking for. True extends boolean just like false would extend boolean. So true extends boolean, and therefore our logic gives us true, but we expect false because true is not the exact same type as boolean. It's a narrower type than boolean. And look here as well. We have an object with the property A has value capital A string, and then we have an object with a read-only property A has value capital A string as well. And we're checking if this extends this, and the thing is, it does, right? It actually does. And so our logic returns true, but we should return false, not true, because these are not the exact same types, right? By the way, this extends this because read-only is a TypeScript only thing. It doesn't exist in the JavaScript space. So when you run an extend on this object, so you can assign this object to this and this to this, either way, TypeScript won't complain. But when you check for equality of types, which we'll do shortly, these are not the same things. As symbols go, they are not the same symbol. This has some READ only characters here that this doesn't have, and that makes it a different symbol entirely. Same thing applies here. We check if this extends this, it happens to, so we return true, but we're expecting false. And here, we check if 1 extends 1 or 2, it does, right? But it's not equal, they're not, 1 union 2 is not the exact same thing as 1, right? So we're wrong in these occasions to return true, and the test cases are telling us to expect false. So what do? We need a more rigorous check for whether the type we're looking for is a type in the tuple. And funny enough, we do have a rigorous check called equal here, and if we replace this tt extend u check return true or false with just that equal utility type, we're going to check if the value in the tuple tt is equal to the value we're looking for u. That in itself will return a true or a false depending on what the case is, and voila, that fixes our issues. But we're not done. This challenge tells us that we need to, basically all these challenges tell us that we need to, I think at least for the easy challenges, we need to implement these utility types without relying on other utility types. So we need to implement our own equal utility type. And this is where the real interesting thing is. Like, we implement equal by using our understanding of what a symbol is. So let's take this case where we have two objects that basically extend one another, right? How do you create an equal utility type that can check the equality of these two objects? From now on, let's look at them as symbols. The answer is create two symbols. Create one symbol based off of this object or symbol. Create another bigger symbol based off of this object or symbol, and create them in such a way that those super symbols or symbols we create from these objects will only be equal to one another if these symbols or these objects were equal to one another from the get-go. So let's go about creating that. Let's define the type equal. Let's say it takes S1 and S2, and we're tasked here with creating something that compares the two symbols we create from S1 and S2 to check whether they're equal. It turns out that in TypeScript, one way you can create unique symbols is by using function types, particularly arrow function types. And so if we create function types as unique symbols and then compare those function types against one another in such a way that those function types will only be equal to each other if these symbols were equal to each other to begin with, then we have an equality operator or an equality utility type. So let's get cracking. What we're going to do is func extends func, and if func extends func or func symbol extends func symbol, we're going to return true, else we're going to return false. So this is the general gist of what we want to do. We're going to create a func symbol 1 based off of S1 and another func symbol 2 based off of F2. So let me just close that func symbol 1 and func symbol 2 in their own scopes, and then get into the business of defining a function type. Function types in TypeScript are defined this way: they take something and then they return something. They return, let's say, any. That's a generic type. That's the, I think, smallest thing you can expect. Let's make this a generic type that takes a type T and returns any. Okay. T and returns any. We can copy that over here. Put that there. In this case, let's remove the equal operator we have here. Cool. Right now, okay, actually let's not do that. Let's name this my equal. So we're going to use my equal here. Awesome. Right now, my equal is comparing two identical symbols created from function types. These two are identical, so they will always be true, and that's causing issues where we have false cases. We need to fix that. We need to make it such that this symbol, function 1 symbol and function 2 symbols, are different if S1 and S2 are different. So how do we do that? I cheated and just memorized that we can do this, right? We can check if the generic type we're expecting, T, extends S1. If it does extend S1, we can return something like 1, or we can return something like 2. I think we can actually return true or false, doesn't matter, right? And then if T extends S2, we can also return true or false. So in that way, if you really look at this as just, I don't know, a string of letters, that's how I like to think of symbols, like just a string of characters. The only way this unique string of characters will be equal to this unique string of characters is if S1 and S2 are identical. Unfortunately, if we swap in A object A value capital A for S1 and read-only A value capital A for S2, they cease to be identical. When you spell out all the characters in the S1 function symbol, you end up having less characters than you have in the read-only A function symbol. So that's how I understand this equality operator. That was what I found most interesting about this challenge. Yeah, I think I spent most of the time on this challenge as well, but that's basically it. Symbols. Keep symbols in mind whenever you want to do like strict equality checks, or just keep the equal utility type in mind. You don't bother reinventing the wheel. And remember that you can convert a tuple type to a union type simply by indexing into it using the number type. Yeah. And also keep in mind Boolean logic. True union true is true, true union false is false. But in TypeScript, true union false is Boolean. Yeah, TypeScript has its quirks. So let's move on. We're almost done. We have just 3 more challenges to go, and we'll be done with all the easy challenges in the TSC repo easy challenges. So push is very similar to Concat, except that we want to we're just pushing one item, not a whole array. So let's go in there and let's implement a push utility type. What's the time? 8 o'clock. Yeah, so push, given an array and some value, push the value up onto the end. That's basically maybe we should start by saying what we expect. We expect T to be an array of any type and then U, and so we're going to return, we'll spread the value of T and then we'll just add on U. That's all push is. That was very simple. It's just like JavaScript actually. Unshift is very similar to push, except rather than pushing it on the end, we're pushing it at the beginning of the array, so it's just a matter of ordering really. Let's go in, take the challenge. Let's see, I want to load up the final challenge while that's loading. Okay, cool, awesome. Yeah, so what are we saying? We have an array, we have 1, push it to the beginning, there's nothing else, so this stays in 1. We have 1 to 0 end up at the beginning, we have 1 2 3 Boolean ends up at the beginning. So again, this is an array type. Notice how we say this is an array type without the read-only. I don't know how that comes out practically, but yeah, we don't need the read-only because this is literally an array type. It's not a tuple type, it's an array type. Still don't understand the difference except that there's no read-only and these are not created using the asconst assertion. Cool. So the next thing is that first of all we put U in front and then we spread T. Voila, we're done. Those were very straightforward. The last thing is my parameters. This was maybe the third most interesting challenge third most interesting challenge of all the challenges. So the idea is you're given a function, and so for instance, here's the function. It takes 2 arguments, arg1, arg2 of type string and number, and returns void. Returns void. This is value space, by the way, so don't be confused if you're seeing the return type before the array operator. It's value space. This is how it looks like in value space. Okay, so given a function, just return an array of the types of the arguments. So here string number, here boolean object, here nothing, empty array. Long story short, recall what we did with symbols. think it was nice that we spent so much time harping on symbols, because symbols most recently, and also when we used infer much earlier on when we're doing includes, we're going to use those things together. Symbols is just by the way, but really what we're doing here is using infer. My parameters using infer, I think I should also say that one thing you may try to do is say t return argument, because I think there's an argument property in every function that you can access within the body of the function. But that didn't work. I don't know why. I think it should, but it doesn't work. Okay. Too bad. Let's move on. Let's really focus on what we did when we're doing includes, right? No, not includes. I waited. We knew we were expecting some promise that took some value, so we extended. We told Typescript we're expecting some promise that takes some unknown type in the parameter scope. Then we went in the block body scope to go more specific, and that's exactly what we're going to do here. They've already given us as a hint that we are expecting. Oh wait, we need to equal. Okay, we need to reload this because I don't think the environment loaded properly. Those imports shouldn't have squiggly lines. Cool, we're good now. All right, here we're saying this parameter type extends a function type. That function type returns anything. We don't care. It takes a number of arguments. We don't know how many, but we know that those end up being an array of how do I put this? Imagine you have an array of arguments, right? Each of those arguments of any type, so that we have an array of arguments of any type, and we are spreading them. That's how I understand the syntax. It's not really straightforward to me. What we want is to get the type of this array that we're spreading. That's literally all we want. If we try to do that in the parameter scope, we will fail miserably. So let's not try. Instead, let's go into the body and do the exact same thing. So we know that t extends some function, right, that takes arguments, and the arguments are of some type. Because we're using extends in the body scope, we need a ternary operator. And let's just do any for starters. What we're going to do is we're going to infer this type, and then we're just going to return our infer type, and I think this is never, because we know for the fact that t does extend a function type. We need to complete this by saying it returns any, I think. Cool. So we know for a fact that t extends a function type that returns anything. So we're never going to get into this case where t does not extend a function type. That's out of the question. But we haven't made progress. We need to infer what type this args is. So let's say, I think we can do something like infer u. Okay. And we can only use infer u in the positive scope. So let's just use u here. Ooh. Infer u. Oh, array. That didn't work. That didn't work. It must be something to do with the way I'm using these braces. Infer. Can I just infer? No, it says that we expected something. So my parameters, yeah. Okay. I want to know what error this is. Expected a comma. What's the question is really what's the syntactically correct way to infer the type of args? Of type any. This says u doesn't exist. Type any. I want this as a type. Okay. Type infer u about that. And u. Okay, cool. It was the array thingy. So here we infer the type of the args as u, and then we just return that. This was a bit difficult to understand. I didn't figure it out when I tried to do it the first time. I had to read it, but then on reading it, kind of makes sense, especially given what we've done with awaited. So that concludes all the 13 easily challenges, and on day 15 of my 65 days of TypeScript challenges. And I'm really excited that I'm done with those. I'm really excited about what I learned from those. I hope this video is helpful to somebody. Of all my videos, I think this is the only one I will try to timestamp because it has all the solutions. If you're a fan out there who's like looking at my progress and growth, thanks. It's people like you that I imagine are out there that keeps me going in terms of recording this. Yeah, this was fun, and look forward to continuing with the medium level challenges going forward. Bye.